What is an exponent? An exponent is a figure that shows the number of times a number can be multiplied by itself. It comes in this form: x to the power n. X is a number known as the base, while n is the exponent. This expression shows x can be multiplied by itself n times. For example, take 5 to the power 3. 5 is the base and 3 is the exponent. This shows can be multiplied by itself 3 times. Is a radical. A radical is a number that in this form: x to the nth root. It can also be written in exponential form, or it can also be written as an exponent: x to the power 1 over n. Take 5 to the third root. This is a radical. It can also be written as an exponent in this form: 5 to the power 1 over 3. Okay, now that we understand what radicals and exponents are, let us solve some problems that involve radicals and exponents and see how we can go about them. So let's take x to the power 2 times y to the power 3. Let me just take this back a little. Okay, yeah. Then over z to the power 2. So how do we go about this problem? Well, this thing we can split it in this way. We can write x to the power negative 2 okay, then y to the power 3, and then multiply this by 1 over z to the power 2. Oh, sorry, it's supposed to be negative 2. It's supposed to be negative 2. All right. So where do we go from here? Well, what you should remember is that under exponents, say if you have x to the power n to the power negative n, then this is the same as writing x, no, not x, 1 over x to the power n. Yes, so when you have x to the power negative n, that's the same as writing 1 over x to the power n. And this is what the rule that we are going to use here on x to the power negative 2 and z to the power negative 2. So let us write this now. You're going to write 1 over x to the power 2 multiplied by y to the power 3, and then you're going to write 1 over 1 again over 7, oh, not 7, z to the power 2. Okay, so where do we go from here? Well, this is the same as writing y over x. So you have y to the power 3 over x to the power 2. And then this is same as writing y divided by 1 over z to the power 2. So you just write it in this form. Wait, let me create some space here so that it's easier for you to see. You get y to the power x to the power 2. Then you have 1 divided by 1 over z to the power 2. All right. So where do we go from here? Well, remember that if you have say n over x divided by b over c, yeah, something like that. What you do is that you change this division sign to multiplication. By the way, this dot is just another way of writing the multiplication sign. If you want, you can write it like this, but usually I just prefer putting this dot. It's another way of writing multiplication sign. So when you change this to multiplication, this one will go up, and then you put b down. Yeah. And then you maintain your n over x. So this is the principle that we are also going to use here. So now you are going to have y. There isn't much space here. So you're going to have y over x. Then this z will go up when you put multiplication here. It will go up, and then you multiply this z by 1, which will just give you z. And then you have it. You will have your simplified answer. Usually they will just ask you to simplify this. So we have simplified it, and then we have this. Then we have this. So we have simplified. Let us do 1 on radicals now. Let us just do 1 on radicals. All right. Right. So which one on radicals can we do? Say you have this radical. Remember, a radical always comes in this form, where you have a number in a square root. Now here you can, I don't know how you can read it, the 4th root of 48. This simply means that we have to look for a number that you can multiply 4 times, because there is 4 here, to give us 48. Now such questions in radicals, they'll just ask you to simplify, because it is actually hard for you. You will not find a perfect number that you can multiply 4 times to give you 4. So usually they will just ask you to simplify. So let us simplify this one. So what you have is 4. Now 48 is a product of multiplying 16 and 2. So what you do, you have 16 multiplied, remember this dot is multiplication sign, and then now you are going to have this. Then now you are going to have this, right? So now you have split it. You have split it. Now here we can actually find a number that you can multiply 4 times to give you 16, and that number is 2. So you have 2. But here we cannot find a number that you can multiply 4 times to give you 2. So you just leave it like this. Basically, they'll just ask you to put a radical in simple form. So we have simplified like that. Let us do another one on radicals. Let us do another one. This one is actually very, very simple. It's actually very, very simple. Say you have alright. So how do you simplify this radical? Well, remember we said that a radical comes in this form, and then there should be a number here, then you have that. Now, this is a form here. Here, there is actually a 2. When you see a square root like this, and there is nothing here, there is actually a 2. This is a square root. So it's in this form. So how do you simplify this one? Remember we said that you can write this radical in exponential form. So in exponential form is going to be x to the power 1 over n. This n will be the denominator. So that's the same thing here. We are going to do this. And there you have it. You have solved your radical. So these may seem simple, guys, but sometimes you can find challenges in radicals. So my advice is that you practice as many questions as possible on radicals and exponents, because you'll be encountering them in mathematics and even in some other mathematical courses. So it's important that you practice as many questions as possible on radicals and exponents. So guys, this is where I end, and I hope to see you next time. Thank you very much for watching.